Hello students. In this class we'll discuss detailing about types of mirrors. Okay, two types of mirrors are there: plane mirrors and curved mirrors. Curved mirrors also called as spherical mirror. Okay, these are of two types: concave and convex mirrors. Okay, so these concave and convex mirrors are called spherical mirrors, right? Why these are called as spherical mirrors? Try to take a ball and cut it into two pieces such that one is big and one is small. So try to observe small piece. You can see like this, okay? So if the reflecting part is cave, like a cave, then it is called as convex mirror, okay? Reflecting part, okay, reflecting part is like a cave, then it is called as concave. Okay, so in the name itself you just observe cave. If you enter like this, means this is a reflecting surface, this is like a cave. That's why just for remembering purpose I'm telling, if it reflecting part is like a cave, then it is concave mirror, and the reflecting part is this outwards. Okay, this is the reflecting part, then it is convex mirror. Okay, so these two concave and convex mirrors are part of a sphere, right? Yes or no? So these two are part of a sphere, that's why these are called spherical mirrors. Okay, so try to observe a spoon. Take a silver spoon of big size. Try to observe. So from this side you can see this is a concave mirror. Okay, it is looking like a cave, right? This is concave mirror, and this back side, if the reflecting surface is outwards, then this is convex mirror. So try to observe your picture from this. Try to place in front of your face. You can see the image. How we can see the image? Your image, this is concave mirror, right? In concave mirror, image is inverted, and the size of the image is smaller than the size of the object. If you bring very close to yourself, then you can see your magnified image. Okay, so concave mirror is the only mirror which produces a image of a inverted or magnified image. Okay, so try to observe from back side. So you can see your image straight, upright, and a smaller image compared to your size. Okay, so in concave mirrors, what happens? Try to compare these three mirrors. Okay, plane mirrors, concave, convex. The image, see, what about the plane mirror? It is, the surface is flat, right? Flat surface. Okay, so these concave, curved inwards, curved inwards. Okay, so what about these curved outwards, curved outwards? Okay, so next, what about if I suppose a parallel beam of light is incident on the plane mirrors, what happens? Try to see here. Suppose let us consider this is a plane mirror. Okay, so this is the back side of the mirror, this is reflecting part. A parallel beam of light incidents on this plane mirror, what happens? It's reflect back in the same direction. Okay, like a parallel lines. Okay, next, a parallel beam of light falls on a concave mirror. Okay, concave mirror means this is the back side of mirror. Suppose parallel beam of light falling on this, then what happens? These reflecting rays or converges at one place. Okay, it converges at a focus point. So this concave mirror is also called as a converging mirror. Okay, what about convex? If the parallel beam of light falls on incident on this convex mirror, they diverges. Okay, they diverges. So that's why these convex mirror is also known as a divergence diverging mirror. Okay, so parallel rays remain parallel. Okay, so here what happens, parallel rays converges, right? That's why it is also called converging mirror. Okay, and this convex mirror is called diverging mirror. Diverging mirror. So what about image? Always image formed by a plane mirror always forms a upright, always forms upright image and of the same size. What about concave mirrors? Inverted image or magnified and upright image. Okay, so what about convergence? Always forms a upright and diminished image. Okay, diminished means smaller size. Okay, so these are the images formed by these three types of mirrors. Okay, so what are the applications you know very well while combing, while making up? Okay, we use plane mirrors. Okay, so what about concave mirrors? So shaving mirrors. Okay, while shaving, okay, to shave clearly, if the mirror is very close you can see your magnified image, right? To shave properly, in saloons, while shaving they use concave mirrors. Okay, so in vehicles, rear view mirror and side view mirrors are of convex mirrors. Okay, side mirror, these are convex mirrors. These are general applications I'm telling. Try to think of more examples where these concave, convex and plane mirrors uses. Okay, so try to observe with the help of a spoon. Okay, so we already discussed in the last class the laws of reflection, right? So suppose let us take a parallel beam of light. I am drawing parallel beam of light. If the parallel beam of light incidents on a plane mirror, what happens is they reflect in the same direction, like this. Okay, next, in case of concave mirror, they converge at one point, right? Okay, they converge, and here in this case they diverge. Okay, so in yesterday's class we discussed laws of reflection, right? So what are the laws of reflection? First one is angle of incidence always angle of incidence incident is equal to angle of reflection. Okay, and second one is incident ray ray, reflected ray, and normal lie in the same plane. Okay, so we discussed these two laws along with the example. Not only these two laws obeys by these plane mirrors, but also obeyed by these both concave and convex mirrors. Okay, so try to why this always angle of incident is equal to angle of reflection. Let us see with an activity. Okay, so I'm taking, okay, let us take a cow is there. It want to pick a grain from one tree. Say suppose say one tree is there. Okay, a point A. Okay, a crow is sitting on this tree at point A. Okay, it want to come and sit at B, but in between these M and N surface, grains are there. Okay, so grains are there. So this crow is very smart. It want to take a grain from this ground, and as soon as possible, means very quick or in less time, it want to pick a grain from this ground, and it want to sit here. Suppose let us take some point. I'm considering these points C, D, E, F or the 4 points. Let us assume grains are there at these 4 points. So from which point it can took and it can go and sit in less time, we have to find. Okay, so let us take the crow want to take a grain from the C, and it want to go and sit D. Okay, and the next E, D, and next F, find. Okay, so what are the paths it has to travel? A, E, A, C, B, first one, and second, comma, A, D, B, and A, E, B, comma, A, F, B. Among these 4 paths, which one is very least path? Which path takes least time? So we have to find. To find that, I am taking duplicate of these paths. Okay, so suppose let us take G. These FG is equal to FB. Okay, let us consider FB is equal to FG is equal to FB, and AE is equal to EB is equal to EG. Okay, next DB is equal to DG, and CB is equal to CG. Okay, here observe roughly which one is forming straight line. AE and EG is forming straight line. Always if any object or anything traveling in a straight line, then it is curved and making some angle, take a least time. So here which one is taking least time? AEB. So ACB, suppose it want to travel ACB, then it has to travel AC plus CB. That is equal to AC plus CG, right? It has to travel like this. Like this. It is bending. Okay. Next one, ADB. ADB. It want to travel ADB, then AD plus DB. That is equal to AD plus DG. Okay, and second case AEB. AEB is equal to AE plus EB. That is equal to AE plus EG. This forms a straight line. If you draw perfectly, you can see straight line. So always the object which travels in straight line will take a less time. Okay, so try here these AEB is takes a least time to take a grain. A crow has to travel, it has to pick a grains from E point and it has to sit in a B to reach in less time. So try to draw these only these case. Okay, so take a tree and A, point A, and here point B. So it is picking from here and it is reaching here. So try to at point E, try to draw a normal E and E dash. Okay, so try to measure these angle. How much you will get? Suppose that 60 degrees you got. This also will get 60 degrees if it is 30, 30, 20, 20, 20 like that. Okay, so here in case of crow, this is the case, right? Like crow, in this case light also takes a shortest path. Okay, so light also will take a shortest path to reflect. So suppose take a light, it is falling on this so let us consider this is a mirror, plain mirror. Light is traveling and incidenting on this point E and it is reaching point B. So always light take a shortest path, not a long path. Okay, so that's why you will get a angle of incidence is equal to angle of reflection. Suppose let us consider this is an incident ray and this is reflected ray. And this is incident ray. So this is angle of incident and angle of reflection always equal. Okay, so this is the case, this is why, this is the reason behind angle of incident is equal to angle of reflection. If you observe this figure, you see in the same plane angle of incident, angle of reflection, normal as lying. So these two cases are row based, right? This is a activity to prove light takes shortest path and also angle of reflection is equal to angle of incidence. Okay, so if you want to study or if you want to observe carefully about these curved mirrors or spherical mirrors, you have to understand some terms related to these mirrors. Okay, so I'm taking spherical mirrors. I'm studying deeply about the terms related to spherical mirrors. Okay, in spherical mirrors, first of all I'm taking concave mirror. Okay, first concave mirror. So you have to know very well about these concave and spherical mirrors, especially because you will understand the plane mirrors easily, but where is come to concave and convex mirrors, these are very important till you are intermediate. Okay, so how these what are the nature of the form image formed by these concave and convex mirrors, and everything is very important. Okay, try to listen carefully and understand the terms related to these concave and convex mirrors. Okay, so I'm taking a sphere. This is very important for us to define the terms. So this is a mirror. Okay, what type of mirror is this? So I draw these lines means this is a back side of the mirror. So reflecting part is this, right? Reflecting part is this, means this is a concave mirror. Okay, so this is a center of the curvature. Okay, so what is center of curvature? Center of curvature is indicated by C. Just I am writing here only alphabets with which alphabet I am indicating, that I am writing in the figure, and remaining term or I am writing here, I am defining here center of curvature. See, what is center of curvature? Center of the curvature is the center of hollow sphere where the mirror is a part. Okay, so we are cutting the concave mirror from these spheres. Let us consider. So the center of the sphere becomes the center of the curvature of this concave mirror. Okay, center of curvature is equal to center of hollow sphere where the mirror is a part. Okay, next. So this is pole. Okay, pole is indicated by P. Okay, so pole. So what is pole? Center of the concave mirror. Okay, center of the concave mirror is called as a pole. Okay, center of concave mirror is called pole. Okay, so next, what is this? Radius of curvature, R. Okay, so radius of curvature, R. So radius of curvature is the radius of the sphere where the mirror is a part. Okay, it is the radius of the sphere where the mirror is part. Okay, so next, so the straight line passing through the center of curvature and pole is called the principal axis. Okay, principal axis.